In this video, we're going to graph rational functions, and we're going to look at rational functions that where the numerator and denominator has a different degree, and we're actually going to look at these things called wholes, okay? Now, as I look at this example, just kind of eyeballing this right here, this looks complicated. There's a whole bunch of stuff going on. I think you'll kind of laugh when you see what we end up with. But let's go ahead and look at it. Now, any time I have something like this in the numerator, I would say, man, can we factor that, okay? Can we factor that? And if I factor that, you'd find that that's going to factor to x minus 2 times x plus 1 over x minus 2. Now, what you have is, if that cancels, you're left with the function y equals x plus 1. And you might be saying, whoa, this is the easiest function I've ever had to graph. This is just a linear function with a slope of 1 and a y-intercept of 1. And I would say, you're right, okay? So we could do all of this stuff because it still works the same. I could find the x-intercepts algebraically, although you probably know it's going to be negative 1. I could find the y-intercepts algebraically, but you know it's going to be positive 1. We're not going to have any vertical asymptotes, and here's why. You might say, well, in the previous video, our vertical asymptote would have been 2. In a previous video, we would have set our denominator equal to 0 and solved, right? But the thing is, we don't have a vertical asymptote because we don't have a vertical asymptote if this factor doesn't cancel out with the numerator. In this situation, since we have the same factor in the numerator and the denominator, we're not going to have a vertical asymptote. And I'm going to scribble that out because I didn't give me space to write it. But we're going to have a whole. A whole is when we have a factor that cancels. Let me write it out. So when we have that factor cancel out of the numerator and denominator, it's going to create a whole. And you know what I'm saying? Well, where exactly is the whole? And so what it is this factor of x minus 2, it's whatever makes it 0. So our whole is actually going to be at the order pair 2 comma something. And the way we find that something is I take my function and I'm actually going to substitute the 2 into it. So it looks like at f of 2, the y-coordinate is 3. That means at this point right here, let's see if I go to the right 1, 2, and I go up 2, 3, this point right here is undefined on our graph. And the reason why, even though we canceled out that factor, I can't ignore the fact that originally if I'm going to put a 2 into the original function, I'm still going to have an undefined value. But instead of creating an asymptote, that just creates a little hole. And the way you show it is like this. Whoop. So we have a hole at the order pair 2, 3, and no vertical asymptotes. Okay? So, moral of the story, if the factor also cancels in the numerator, it's a hole. If that doesn't cancel in the numerator, it's going to create a vertical asymptote. And then lastly, we can look at our horizontal asymptotes. Let's see if there are any. We have Bobo, Bosco, and Botno. This looks like a Botno because the degree is bigger on top. See how we have a second degree up here but a first degree down here? Since it's bigger on top, there is no horizontal asymptote, and this is going to be our function. And we're done.